As chemists, one of the things that we have to do all the time is to prepare solutions of a known concentration. One of the most common ways of expressing concentration is in terms of molarity, which is moles per liter. In this problem, we have a certain mass of nickel sulfate, 5.87 grams, that's made up to solution of 250 milliliters in a volumetric flask. So the first part of this problem is to calculate the concentration of this solution in units of molarity. Then the second part is to figure out how much of this solution should be diluted in order to make 100 milliliters of a different concentration solution. So to get started, we'll look at the molarity problem. So the first thing is to remind ourselves what molarity is. Molarity is given the symbol M, capital M, and it's defined as the number of moles of a substance, in this case nickel sulfate, per liter of solution. So moles per liter. Now, in order to take our mass of nickel sulfate and convert it into moles, we need to know the molar mass of nickel sulfate. So we've got one nickel atom, one sulfur atom, and 4 oxygen atoms. The nickel weighs 58.69 grams per mole, sulfur is 32.06, and oxygen is 15.999. We have 4 of them. And if we add that all up, we get 154.75 grams of nickel sulfate per mole of nickel sulfate. So this information can be combined with the mass, the 5.87 grams, in order to figure out how many moles we have. If you're not sure how to do that, you'll probably want to look at the math module on unit conversion and dimensional analysis. We'll look at that in just a second. But before we worry about the numerator in our molarity, let's take a minute to think about the denominator. So what we have here is a 250 milliliter volumetric flask. Volumetric flasks are calibrated to contain exactly 250 milliliters, and the uncertainty on that is in that hundredths place, the hundredths decimal place. So if I wanted to convert this number of milliliters into liters, I need to know the conversion factor, 250 milliliters. I need to know the conversion factor between milliliters and liters, and we know that there are 1,000 milliliters in a liter. Now I wrote it this way with the milliliters on the bottom and the liters on the top because I was thinking ahead to my units, and I was thinking about dimensional analysis and the fact that I want my milliliters to cancel so that I get my answer, the volume, in liters instead of in milliliters. So 0.2, trying to put a decimal point there, there we go, 2.5000 liters is the same thing as 250 milliliters. All right, so then how many moles do we have? Well, we know we have 5.87 grams of nickel sulfate, and the molar mass we calculated over here. So again, put the 154.75 in the denominator so that the grams will cancel, and then moles is in the numerator. And if I do that math, I get 0.0379 moles of nickel sulfate. So my 5.87 grams turns out to be 0.0379 moles of nickel sulfate. So if I want to then find the molarity, that's going to just be the number of moles, 0.0379 moles divided by the volume, which is 250 milliliters, or 0.25000 liters, and that comes out to be 0.1517 capital M for molar. And the last thing we have to do is just check our significant figures. Now, if we go back to what we were given in the problem, the nickel mass has 3 significant figures, and the volume has 5 significant figures. So since we're essentially doing a division here, our answer should have 3 significant figures. So our final answer should have 3 significant figures. So 0.152 molar is the concentration of this solution as it's prepared to the correct number of significant figures. Now the next part of the problem was to figure out how many milliliters, or what the volume of the solution should be in order to prepare a 100 milliliters of a 0.02 molar solution. Now remember, that solution that we just made was 0.152 molar. That was our original solution. And so what we're planning to do here is to take a portion of the solution, the more concentrated solution, and dilute it in a 100 milliliter volumetric flask so that our final solution concentration is 0.02. So all the moles that are going to be in this final solution, all the moles of nickel sulfate, have to come out of the more concentrated solution. So the number of moles we want would be 0.0200 moles of nickel sulfate per liter, right? That's what molarity is. And then we'd multiply that by 0.1000 liters. So I've done that step of converting the milliliters into liters in my head and just written down the volume in units of liters. So the liters cancel, and I'm left with the number of moles, and it's going to be 0.00200 moles. So that's the number of moles of nickel sulfate that we need to put into our 100 milliliter volumetric flasks in order to make the concentration what we want it to be in the end. Now, all of these moles have to come from the 0.152 molar solution. So we need 0.00200 moles of nickel sulfate, and that's going to be coming from the volume of, I'll call it C for concentrated, the volume of the concentrated solution times the concentration of that concentrated solution, 0.152 molar. Remember, that's moles per liter. So if I have my volume in liters and I'm dividing, or I'm multiplying by moles per liter, the liters from the volume and the liters from the denominator in molarity will cancel. I can rearrange this so that I have the volume of the concentrated solution on one side of the equation and everything else over on the other side of the equation. So I'm going to write that this way, 0.00200 moles divided by this concentration, 0.152 moles per liter, and that'll equal the volume of the concentrated solution. So you can see moles will cancel here, and I have liters in the denominator of the denominator, which tells me that my units are going to be in liters once I've done that division. And if I do that division, I get as my answer 0.01316 liters. Now, it's kind of hard to measure out that amount of the more concentrated solution, so it's going to be more convenient for us to turn that into milliliters. So just rewriting it here, 0.1316 liters. We know that there's, for 1 liter, there's 1,000 milliliters, and so this becomes 13.16 milliliters. How many significant figures should we have in this answer? Well, going back to what we know, we have 3 numbers that go into this calculation. We've got the volume of the final solution, which has 4 significant figures, the concentration of the final solution, which has 3 significant figures. This 0 is not significant. And then we have our more concentrated solution, which also has 3 significant figures. So our answer should have 3 significant figures, so 13.2 milliliters is the final answer.